Hello friends, myself Gokul Patil. Welcome to our YouTube channel. Today I will talk about the implementation of binary search tree. We have to understand that how we can create a binary search tree. Once we create, how we can search a node, how we can delete a node, and how we can insert other node inside a binary search tree. So the complete implementation, I will show you that stepwise as well, line by line, how the code is work in the compiler. So watch this complete video so that you can understand that how the binary search tree has been created in a C or C++. So we'll start. First I'll just draw a simple structure of the node. Each node contains three parameters. One is the data, one is the left link, other is the right link. So for understanding purpose, here I write three nodes. One is having left link, other is pointing to right link. This is the data, this is the left link, this is the right link. We know the property of binary search tree. Anything which is less than will be in the left side. Anything which is greater than will be in the right side. So if I write 10, anything which is less than 10 will be in the left side. Anything which is greater than 10 will be in the right side. So 12 is in the right side. Now we'll see that first of all we have to create this particular node in a binary search tree. So here I write class binary search tree. Inside that we'll write the structure node. Each node contains three attributes: left link, data, and the right link. So first of all data, so I'll say integer type of data, so I'll take a number. It depends on your data type. If you want to store the alphabet information, use the character as a data type. Then there are two links: node pointer left, node pointer right. So these two links, one is pointing to left side, other is pointing to right side. And then each tree is having a starting point that we can say it's a root. So every tree is start from the root. So root is a pointing which will be point to the left to right link and the data which is set inside the tree. Initially the root should be null. It is not pointing to any other node, so that we will attach the next node after the root, or we can attach the first node as a root node. So first we will write a constructor which will make root is equal to null. So constructor is a same like a class name. Constructor do not have any return type. Constructor automatically initializes when the first object of the class is created. So binary search tree is a class as well as it's a constructor. So root equal to null. So first we initialize root equal to null. And then we'll write a methods which will be required for creation of a tree. So I'll write the two methods. First one is insert and second one is the add, that having the two parameter, starting point of the tree that is root, and second one is the node that I create. I'll show you the detailed implementation of this particular function after the declaration. One more function is display this particular binary search tree. This is end of the class. So after end of the class, we will create a node structure which contain left link, right link, and the data, and the methods insert, add, and display. Now we'll implement one by one that method to understand that how the node is been created. So first of all, we'll write this method insert. So when I write the method outside the class, return type, class name, scope resolution operator, and then function name, or you can say method name. Inside that method, we will write how we are going to insert a node in a binary search tree. So how to create a particular node. So first of all, I want to create the new node. So I will create an object of type node pointer, let's say P1. P1 is a node that I want to attach first in a tree. So I will create P1 pointer of type node. So if I create a pointer P1, it means that it looks like this. This is my P1 because it's a part of node. So node contain data, left link, and the right link. Here you can see in the structure node contain number, left and right link. So this number left and right will be held inside P1. So first of all, we have to create that node. So how we are going to create that node? So first of all, I allocate the memory for the node. This is just a declaration. Memory is not allotted for that node. So P1 is equal to new node. By using this statement, we can allocate the memory. So let's say 500 is the memory allocated to that node. Then we'll read the information from the user. Enter the number. The number that I want to enter inside this particular node. That number I'll read from user, or we can store it directly inside the P1. P1 of number. So that number will be held inside the P1. Suppose I'll read 10, I want to insert this. So first I'll create a node P1, allocate the memory for that node. Then I'll read the number from user and will be stored inside the P1 of number. Then we have to make this left link and the right link should be null, because we are creating a single node. So P1 of left is equal to null and P1 of right is equal to null. This is only the 4 line of code which will create a new node. Every time when you want to create a new node, these 4 statements are important. Using that, we can create a new node. Now using this, we will get a new node having a name is P1. Now we want to attach that node in a binary search. So that node should make as a root node. So that node we have to convert into now root node. So first of all, whether the root is exist for the given tree, whether the tree is null or it is having certain nodes. Now there is no any node inside a tree till now. Now once the node is created, then we have to attach that node as a root node. So we'll write a statement if root is equal to null. We have to check whether a node is there inside a tree or not. If it is not, we'll have to make this node as a root node. So what we'll write? Root is equal to P1. So all the data of P1 is being copied into root. We will alias this P1 as a root. This statement will execute only once in the program execution, because root is only once null. Once it is been allocated with P1, then it won't be a null. So if I execute this function again to insert node in the left side or right side, then this will not execute. So we have to go into the else part. What we do in the else part, this won't be execute if the root is not null. Suppose this is my root node, I want to attach either in the left or right. That is the user decision whether you want to go in the left side or right side. But this won't be executed. So it comes into the else part. What we do in the else part, we'll add the node. So we'll write the second function add and having 2 parameters. And that parameters are, the first parameter is the starting point of the tree and the second one is the node that I want to attach. So here I will pass the node that I created, that is P1. This node I want to insert, and from which point I'll insert from root. So here you can write root. So root is the starting point and this is the node that I want to add or insert inside a tree. This function I can repeatedly execute many times. So we'll write a case of do while cout do you want to continue, and let's say user will enter their choice answer. If they say yes, then while 1. So this function is end. This is end of while and this is end of function. So in this way we'll write a insert function. In that we'll insert a node and call the add function. Only one particular node will create, and if the second node is there, we'll call a add function. Now we will see the add function, how we are going to add the node in a binary search tree. So here I write the function and having 2 parameters. One is the starting point, that is root. The node that I want to insert inside the binary search, that is P1. So we know that anything which is less than will be in the left side, anything which is greater than will be in the right side. So we'll insert the node first in the left side, it means it is less than the root 11. So here we have to write a condition if that temp of number is less than P1 of number. So that number is being compared with this number. So we have created new node and we have a root node. Root node is having value 10. It is compared with that P1 of number. If it is less, we have to check if temp of left is equal to null. Immediate after root node. Immediate after root node, it is null because only one node in binary search tree now. So we have to insert immediately in the left side. So we will write that temp of left is become the newly created node, that is P1. This is end of if. Then we'll check that temp of left is equal to null. We'll insert this, but this condition is not true every time. Already let's say there are two nodes, one is root, one is left side. So I have to insert one more node and that is in the left side. So if I want to insert 6, so temp of left is not null. So this condition will not going to work. Then you have to execute else part. That will call a function add again to reach to the depth of left side. So we will call function add in the recursive call of the function having the first parameter is temp of left. We have to traverse temp of left comma P1. So unless and until temp of left not equal to null, this code will work, and then once it null, then it will be insert that node in the left side. So this is the code which is going to work for the left side. Now if this is true when anything which is less than root, left side will be created. Now we'll have to see on the right side. So else, if followed by else. What we need to do in the else part? In the else part, this condition we have to change, because now instead of less we have to check for the greater value. So we'll write if temp of number is greater than P1 of number. Now this value is greater, else if you can write, or directly you can write in the else part. You can discard this because already I compare with the less value, else will be a greater value. So if you skip this, then also it will work. The else part. The else part will write if temp of right is equal to null. What it means? The temp of right, now it is null, only one node parent is there and nothing in the right side. We will create a new node and that node we have to attach in the right side. So we will check whether temp of right is null. Yes, only one node in binary search tree, so the right side is null, so this condition is true. Then we will add that new node in the right side. So we will write is equal to P1. So that node will be inserted in the right side. Else, now let's say this node is going to be inserted in the right side. We'll have to insert one more node in the right side. So in such a case, we have to traverse till the depth of the right side. So we'll call the function add temp of right comma P1. So it will give the call in the right side. Having parameter P1 is the node that I want to insert. It will check whether it is less than, no, it is greater. So come into the else part, whether temp of right is equal to null. Yes, now temp of right is equal to null, then this node will be inserted in the right side. In this way, this add function is going to be work. One by one, node is going to be inserted in the right side of a binary search tree. So we can add many nodes as you want in a binary search tree. The next function is display. In display function, we have to display a binary search tree either in order, pre-order and the post-order sequence. So we had already studied in order, pre-order and post order. So I'm not going to discuss this again in this video. So you can go through any order traversal like pre-order, in order, post order video. You can watch that video. You can understand everything. If you not understand, you can write in the comment so that I'll again prepare a new video and share with you. So hope you like this video. If you like this video, Kindly subscribe the channel. Thank you.